1989 AB1. We have the function given by f of x is equal to x cubed minus 7x plus 6. The first thing that we want to do is to find the zeros of f. Since this is a cubic function, I'm going to use synthetic division. With synthetic division, we always want to try 1 and negative 1. So if I just plug in 1, I get 1 minus 7, which is negative 6, plus 6 equals 0. And since f of 1 equals 0, that means that 1 is a root. And so I set up 1 in the little box there, and I have 1, and I have to put a 0 where there's no term, there's no x squared term, then negative 7 plus 6. The first thing I do is carry down the 1, multiply by 1, that gives me 1, add down, that gives me 1 again, multiply that by the 1 in the box, gives me a 1, add negative 7 and 1 gives me negative 6, carry up the multiply by negative 1, again gives me negative 6, add together gives me 0. And since the remainder is 0, that means that, again, 1 is a root, x minus 1 is a factor. That means that the other factor is going to be x squared plus x minus 6. And I try to factor x squared plus x minus 6. I'm looking for two numbers, multiply to give me negative 6, add to give me positive 1. And I think that positive 3 and negative 2 make that work. So we get x minus 1 times x plus 3 times x plus 2. And we end up with 0 values of x equals 1, x equals negative 3, and x equals 2. And that's our answer for part A. Second, we want to write an equation of the line tangent to the graph of f at x equals negative 1. Well, to find the equation of a tangent line, we need a slope and we need a point. The point we're going to use is x equals negative 1. To find the corresponding y value, we're going to plug that back into the original function. And so that y will be f of negative 1. Plugging in negative 1, I get negative 1 plus 7 plus 6, and that's going to give me a positive 12. Now secondly, I need a slope, and the slope will come from the derivative at x equals negative 1. We state that the derivative is equal to 3x squared minus 7, and f prime of negative 1 then is 3 minus 7, or negative 4. Now we're ready to put the pieces together. I'm trying to find y minus y1 equals m times x minus x1. I know my y1 is 12, so y minus 12. My slope is negative 4. My x1 value is negative 1, so that'll be x plus 1. And that's the equation of, that's an equation of the line tangent. It doesn't have to be in slope-intercept form. That's fine like that. And so we can go on to part C then. Part C says find the number C that satisfies the conclusion of the mean value theorem for f on the closed interval from 1 to 3. Well, the mean value theorem states that the derivative at some point in a closed interval is equal to the slope of the secant line connecting the endpoints of that interval. And it can be written in this way: f prime of C is equal to f of b minus f of a over b minus a. In a picture, if we had a graph and the curve started at point A, f of a, and ended at point B, f of b, then the slope of the tangent to that curve has to be equal to the slope of the secant line passing through the endpoints there, at least at one point C in that interval between A and B. So to solve this, all we do is find the derivative, which we've done already. That's 3x squared minus 7, and that's got to equal the slope of the secant line, and that would be f of 3 minus f of 1 over 2, and f of 3 is 12. F of 1 we already know to be 0. So 3x squared minus 7 equals 6. 3x squared equals 13. X squared equals 13 over 3. X would be plus or minus the square root of 13 over 3, but because we're only working with the interval from 1 to 3, only the positive value counts. And it says X, but that's C really. And that wraps up this problem.